first of water. So usually this is given to you in the question. So for water, it is 4.184. And then the units are joules per gram times degrees Celsius. So now let's look up the heat capacity of aluminum. So the specific heat capacity of aluminum is 0.900, and it has the same units, joules per gram times degrees Celsius. Okay, so the first thing we need to do is solve for Q. So step 1. Solve for Q, which is also the heat to equilibrate the aluminum temperature. Okay, so to solve for Q, I would just simply need to plug in all the values I had written out up there. So for mass, I converted it to grams. So it's 1,850 grams. The specific heat capacity of aluminum, we looked up and it was the 0.9 joules over grams times degrees Celsius. And delta T is T final minus T initial. So it will be, let's see, -65 degrees minus 150 degrees. Okay, so if we do all the math and try to solve for this, you end up getting -141,525 joules. Okay, so this is the heat that is released, and it will be the same with the water as well. So part 2 of this question is to solve for the mass of water. So just using the same equation, Q equals mc delta T, but I am going to rearrange it so that it's M is equal to Q over C delta T. My Q value will just be the heat that I calculated in the first part of the question. But the positive value, the C specific heat capacity of water is 4.184 joules over grams times degrees Celsius. And the delta T is just 65 minus 25. So this gives us a mass of water of 845.6 grams. Or if we wanted to express this in kilograms, it would be 0.846 kilograms. Okay, so let's see what the junior tutor said. Given values, heat capacity of water is 4.184 joules over grams times degrees Celsius, and they have the heat capacity of aluminum to be the 0.900. First, solve for the amount of heat needed to equilibrate aluminum temperature. Okay, and they got the 141, 525 joules. Then, using this heat, compute for the amount of needed water. Okay, and they also got 846 grams. So I can say that this solution is correct.